Newton's laws of motion are three fundamental principles formulated by Sir Isaac Newton in the 17th century. These laws describe the relationship between the motion of an object and the forces acting upon it. They form the basis of classical mechanics and are fundamental to understanding how objects move under the influence of forces. Newton's first law, law of inertia. An object at rest will remain at rest, and an object in motion will continue moving in a straight line at a constant velocity unless acted upon by an external force. In other words, an object will maintain its state of motion either at rest or moving with a constant velocity unless a force is applied to it. This law introduces the concept of inertia, which is the tendency of an object to resist changes in its state of motion. For example, if a book is placed on a table and not subjected to any external force, it will remain at rest. Similarly, if you slide a ball across a smooth floor, it will continue moving at a constant speed in a straight line until it is acted upon by another force, such as friction. Newton's second law, law of acceleration. The acceleration of an object is directly proportional to the net force acting on it and inversely proportional to its mass. Mathematically, this law can be expressed as F equals ma, where F is the net force applied to the object, m is the mass of the object, and A is the resulting acceleration. This law explains that an object's acceleration depends on the force applied to it and its mass. Larger forces cause larger accelerations, and objects with smaller masses experience larger accelerations for the same force. For example, if you apply a force to a soccer ball and a basketball with the same magnitude, the basketball, which has a larger mass, will experience a smaller acceleration than the soccer ball. Newton's third law, law of action and reaction. For every action, there is an equal and opposite reaction. This law states that if an object A exerts a force on object B, then object B exerts an equal but opposite force on object A. The forces always act on different objects, and their magnitudes are equal while their directions are opposite. For example, when you push a book on a table, the book exerts an equal and opposite force on your hand. When a rocket expels exhaust gases downward, it experiences an equal and opposite force upward, causing it to move upward. These three laws provide a comprehensive framework for understanding the motion of objects and the forces that influence them. They are the foundation of classical mechanics and have profound applications in engineering, physics, and everyday life.